Hello, Ms. Scott. My name is Isaac Altler, and I'm working with Darian Ho and Benjamin Ahumada on the logarithms and the pH scale. The pH scale was invented in 1909 by a guy named Soren Sorensen, who was a Danish chemist. He developed the scale at the Carlsberg laboratory using his previous knowledge of enzymes. He discovered that the effectiveness of certain enzymes was based on the acidity levels of the solution. So there was like an ideal range of acidity levels where certain enzymes worked in. So he created the pH scale to accurately measure it. The pH scale expresses the concentration of hydrogen ions, or H+, as a solution in the solution as a level of acidity or basicity, the two extremes of the pH scale. The scale is centered around water, which has a neutral pH of 7.0. So if I draw a little number line here, you'll see that water is the center of the scale, 7.0, neither basic nor acidic. If a substance has a higher H plus concentration than water, the pH is going to be less than 7. So all of this is pH less than 7, and these solutions are considered to be acidic. If a solution has a lower H plus concentration than water, or the pH is greater than 7, it is considered to be basic. Now, this is a bit confusing because while acidic is less than 7, the H plus concentration is actually higher than water. So H plus is greater than water. And basic is greater than 7, but the H plus concentration is less than water. So you have to take these like opposites into account when creating a formula to calculate pH. Both extremely acidic and extremely basic solutions are considered dangerous and corrosive. Because hydrogen ion concentration levels can vary so greatly, logarithms are used to make the pH scale more digestible and manageable. So H plus concentrations can vary by hundreds of thousands, but the scale really only goes from 0 to 14 because it just compresses those thousands into a very small scale using logarithms. Each number on the scale uses logarithms to make it more digestible by increasing or decreasing by a factor of 10, meaning that a solution with a pH of 2.0, which would be right here on the number line, has 100,000 times more hydrogen ions than a solution with a pH of 8.0, which would be right here. They're very close on the scale, but this has 100,000 times more hydrogen ions. That's why logarithms are used, to make it much more digestible on the large scale. Now, the equation used to find pH levels from the concentration of hydrogen ions is pH equals negative log H plus. Now let's break down this formula. pH is what we're trying to find. H plus is what we know. The negative, remember how I said the more H plus ions it has, the more acidic it is, even though the pH gets lower? So that flippy thing is expressed by the negative, and log is used to express factors of 10 in between each level on the scale. So this is the formula we will be using in our problems to find pH from H plus ion concentration and vice versa.
Alright, this is Ben over here. Wearing a suit, so I'm much more sophisticated than Darian and Isaac. So, I don't know if you can see my face. This is how the tripod goes. Hi. So, let's start off with some pretty basic problems using the pH scale. So, the hydrogen ion concentration. This marker's dying. Hydrogen ion concentration of a certain solution is equal to 1.0 times 10 to the negative 7 m. So with this, we need to find the pH, and we need to find if it's a base, an acid, or just water. So we can use the pH formula. So pH is equal to negative log of the hydrogen ion concentration. So we can figure it out. pH equals to a negative log 1.0 times 10 to the negative 7th m. So, with this, we can find the pH is equal to, let me write it out, pH is equal to negative log 1 and that would be and then you would add log 10 to the negative 7th. So after that, we can find, negative log 1, so negative log 1 would be 0, because that's how logarithms work. Everything 1 is 0, because any number that 0 power is 1. And then log 10 to the negative 7, it will be negative 7. So, the pH, I messed that up. So the pH would be the negative 0 minus 7. So of course, pH equals to, pH would be equal to negative of negative 7, I think. And then I would make the pH 7. So if we look at our pH scale, we'll see, let me look. So if we look at our pH scale, then we will see that pH less than 7, that is an acid, right? And then pH above 7 is a base. But we got exactly 7. So 7 is neutral. And it just so happens that neutral is just water, because pH is based off water. Alright, so let's do another one, because let's take this one a bit short, because I'm running out of time before I have to pass it over to Darian. So, we have the pH of marinara sauce is equal to 4. So, what is the concentration of the hydrogen atom? So what is H equal to? H that equal to? Alright, so this is just this problem, but reverse. Look on this head, people. So if you write the equation again, pH equals to negative of log hydrogen, whatever. These are right. Negative log hydrogen. You can replace that with 4 equals to negative log of the hydrogen. So if you remove the negative, negative 4 equals to log hydrogen. Oh no, we can see. Can you see that? Good. And then finally, we just rewrite that in exponential form. Hydrogen is equal, hydrogen concentration is equal to 10 to the negative 4, so this is log 10 over here, which means that in units, in moles, the hydrogen ion concentration is 1.0 times 10 to the negative 4th. And you can see, put this back into the equation, pH, the pH will equal up to 4. I'm not doing it all out, but it will equal 4. So there you go. We learned how to find the pH, from the hydrogen ion, and we learned how to find the hydrogen ion from the pH. Over to you, Darian.
Our example problem is Ella Marie Blanchette prepares 2 acidic solutions. She knows the hydrogen ion's concentration of the solutions are related by the equation hydrogen ion B is equal to 1/5 times hydrogen ion A. Ella measures the pH of solution A to be 3.7. What we're finding out is, what is the pH of solution B, and how much does the pH change between the 2 solutions? What we know that the pH of solution A is 3.7, and we know the equation pH is equal to negative log hydrogen ion. So we have to find the concentration of A by using 3.7 is equal to negative log H plus A. Now once we do that, we have to multiply both sides by negative to cancel out that, so it'd be negative 3.7 is equal to log hydrogen ion A. Since we know log is base 10, we can make the other side by doing H plus A is equal to 10 minus 3.7 using the base property rules. Now to find out what 10 to the power of negative 3.7 is, to find what that is, we have to put it into a calculator, and then we find out that it's 0.0002. Now we have to find the hydrogen ion of B. Now to find this, we have to use the equation that we had earlier. H plus B is equal to 1/50th A. So now we have to use what we know. So it's going to be H plus B is equal to 1/50th 50th times 0.0002. Now we can use scientific notation to find out what it's equal to. So it'd be 4.0 times 10 to the negative 6. So that is what hydrogen ion B is equal to. So now we have the hydrogen ion concentration of A and B. We can now use the log equation to find the HP of B. Now we have to use the equation PHB is equal to negative log times 4.0 times 10 to the negative 6. Now we use the logarithmic product rule to get PHB is equal to negative log 4.0 negative 6. Now when we put log 4.0 into the calculator, it's roughly equal to 0.6. And now we have to use this to find the pH of B. And we could do this by doing 0.6 minus 6, which gives us negative 5.4. So now we know that the pH B is equal to negative times negative 5.4. So now the pH B is equal to 5.4. And now since we have this, we can find the change in the pH. Now with this, we can use the equation delta pH is equal to pHB minus pHA. And now we have both information. pHA is 3.7 and pHB is 5.4. So now we do pH is equal to 5.4 minus 3.7. And now once we calculate that, the pH change is 1.7. So to wrap up what work was shown, the pH of B was 5.4, and the change in pH was 1.7.